All right, here we go. So you're probably wondering why all of a sudden we went from exponents, right? We did all these things with exponents. We did scientific notation that had exponents. And then all of a sudden we switched to roots, right? And you're like, what the heck? Why did we switch? All right, so the good news is they are related. So remember, radical is just another name for roots, right? Those are the roots that we've been dealing with it. We're going from radical form and exponent form today. They mean the same thing. That's the exciting thing. So we can write any root as an exponent. How excited are you? Roots can be written as exponents. Exponents can be written as roots. So that's kind of exciting. How, right? Yeah. So let's talk about that. So if we have square root of 7, okay, it can be written in exponents. It's going to have a fractional exponent. So your 7 is your big number. Okay, your exponent is going to come from 2 different areas. So you're going to have a numerator and a denominator because it's going to be fractional exponent. Your numerator is whatever power this is raised to. If there is nothing written here, what power is it raised to? A 1. That is your numerator. Numerator. Your denominator comes from your root value. What is your root value there if there's nothing written? A 2. So 7 to the 1/2 is the same as the square root of 7. Square root of 7 is the same as 7 to the 1/2 power. Okay, so that's going from radical form to exponent form. So a lot easier when they give you some numbers to deal with. Let's say we have the cubed root of 9 raised to the 2nd power. 9 to the 2/3. Makes sense? 3 is your denominator. Whatever it's raised to becomes your numerator. Yes, question.
Is the 3 just like a number outside?
Nope, the 3 is the root value. That 3, the little 3 in the root. That's why I was trying to draw it in my, because the whole thing is getting raised to the 2nd power. Okay. So that's radical form to exponent form. So obviously they're going to ask you the other way too. They're going to give you an exponent and they're going to say write it as a radical. So we're converting back and forth to get used to it. So let's say they give you 10 to the 3/4 power. What becomes my root value? Under it is the 10. What becomes the root value? The 4. So I have the 4th root of 10 raised to the what power? 3rd. Okay. What if I have 6x raised to the 2/3 power?
Will it always be like the whole thing raised to the 3rd? If you have like raised something?
Yeah. Okay. What if I have that? 6x is going to go in that root right underneath. What is my root value out here? The 3. And it's going to be raised to what power? The 2. Okay, I want to show you how important parentheses are, because now I'm going to have this. What is the only thing getting raised to that 2/3 power? The x. So I'm multiplying against that 6, right? So that 6 is not going to go underneath that root. That 6 is going to stay on the outside. So do you see why it's important to have parentheses? Because a lot of times they're going to give you something like this, expect you to write it in exponent form. If you forget your parentheses and you write it like this, I'm going to count it wrong. Because both of those things are getting that root and getting raised to that power. So they're going to ask you something like this. You're going to write it. Some of you are going to forget to write your parentheses and write this. That is not correct. It's this one. That is why parentheses are important. Okay, now I'm going to take that same kind of example, but I'm going to make this a negative 3/4. I have 10. Right. Because what's getting raised to the 3/4? The whole shebang, 10. Yeah, that's just a number. There's not two things here. What if I had 10 to the negative 3/4? Well, same idea. 4 becomes your root value, so I have the 4th root. Put the 10 inside, raised to the negative 3. Oh no, I have a negative 3 exponent. Am I going to let you do that? No, he's not happy upstairs. Where should he go? Downstairs. Bring him downstairs. The only thing that changes when you bring him downstairs is that that negative is now a positive. What's a good placeholder for up top? A 1. And then I'm going to let you leave it like that. I'm not going to make you keep going. Okay, that's for algebra 2 to deal with. Okay, so most of your worksheet's converting from one form to the other, back and forth, back and forth. Then at the very end of your worksheet, it's going to ask you to simplify. So that means that we're going to take and we're going to do everything we know, put it all together kind of thing. So they're going to give it to you, they're going to give you something in exponent form, like 9 to the 1/2. Okay, we haven't been dealing with exponent form, so we're going to change it back to radical form and do it just like we did for our quiz yesterday. Okay, just like we've done for the worksheets for the past 3 days. So we're going to make this into radical form. So that would be the square root. Now, do I need to put that little 2 in there? No, because I'm going to assume it's a 2. If you put it in there, is it wrong? No. Okay, so square root of 9 raised to what power? The 1 power, right? Do I need to write the 1? No. Not technically. Is it wrong if I do? No. Okay, so I'm going to put the 2 in there and the 1 in there just because that way if it's there, it's there. If it's not, it's not. Okay, I don't care either way. You can write this either way. These are the same. But we have to keep going. We need to simplify. The very end of the worksheet says simplify. That means I need to go as far as I can. Can I get any groups of 2 out of 9? Yeah, what is the square root of 9? 3. And then if I have 3 to the first power, what's that? 3. Done. So you're going to be given it in exponent form, make it into your radicals, and then do that like you've been doing for the past few days. Okay? All right, let me hand out the worksheet.